Hello, everybody. Hope you guys are doing well, and welcome to the third Obelisk update video. In this video, we will discuss our brand new architecture and some new nodes and some new updates to our platform for the Visual AI Agent Builder. And we also are adding a deployment layer, and we have added the autonomous layer. So we'll be discussing a couple of code updates for the architecture for those that are looking to contribute and just kind of follow along with how our code base develops. And then we'll focus on the visual editor that we're going to be opening up to the public. And also you can currently also locally run this, but if you don't want to set it up yourself, we'll be able to visit the website build.theobelisk.ai and get set up really easily. All right, so let's start with the code base here. If you've noticed, we have a couple new folders and we've changed the file structure a little bit. We've got rid of the LLM and the memory folders here. We moved everything into core because now we have a node-based architecture where everything is a node, and we have a node registry that shows you which nodes are available. There's memory storage, model loader, and if a node needs some extra logic, extra classes, we can create a separate folder for this to add some extra utilities for memory nodes or the inference node. So all the logic lives inside of each node, and you can check it out. For example, the model loader is just going to load the model. Currently, it's just going to load the Qwen 3 model, and you can see it initializes the Obelisk LLM instance. And we also have the inference, which is going to have a node.py, which is like the main file, which is the inference node, and it contains some logic, has the base node logic, like execution functions. But essentially, the architecture works in such a way where everything lives inside the nodes, and the engine is going to execute the nodes. So the execution engine is going to take the nodes, the workflows as JSON file, and it's going to do some validation and essentially run the workflow as a subgraph. But since we have autonomy, we added the runner layer, which is the kind of continuous slash autonomous layer on top of what we have, which allows for deciding when to run workflows. The code is a little bit complicated and it's quite 600, 700 lines. It does need a refactor, but that's still the general architecture is there. We might need to do some modifications to the runner to make it more robust. But for now, this is kind of the architecture we have, and it seems to be working really decently well. And again, it's inspired by Comfy UI's already proven industry standard node-based design for AI video generation. There's also a Docker folder here, which is meant for doing Docker deployments. And this is going to integrate with our hosting AI agent service, which will essentially allow you to deploy your agent to the cloud. So if you have an NFT, you will be able to deploy for free. Otherwise, we might have some fee, but we also have some free spots for beta testers where you can just simply build an agent, hit deploy, and it will start living in the cloud. This is the current workflow. It looks kind of complicated, quite the noodle soup. What we are going to do is get rid of a lot of these nodes and kind of start fresh and show you guys how to build this from uh, start to finish. If you want to customize this or maybe make it your own. So we're going to leave a couple of notes just so we don't have to recreate and re-add a lot of text. So these are just basic text nodes. But let's assume that you're starting with nothing, okay? Absolutely nothing. Forget about these nodes for now. So we're going to start completely fresh and create a couple of different AI agents along the way and show you guys how this works. Again, this is mm, based on Comfy UI's AI video generation workflow. So if you guys are familiar with that, it should be very easy to follow along. If you're not familiar with that, it's still very intuitive. So when you're first creating an agent, the first thing you would definitely need, I like to start with nodes that you definitely would need, is the inference. You're going to need some sort of way to interact with the model and to get its output, because that's kind of at the core of an agent, at least one inference node. So we start with an inference node, and as you can see, there's a couple of inputs and a couple of outputs. Not all the inputs or outputs are always required, so it just depends on the node. In this case, you can just look and see, okay, the model would definitely need a model because the inference nodes needs a model to load. So the next node we can do is the model loader. Take the model loader and connect to the model. To open up this menu, you can just double click or you can right click. the model loader will load the model, in this case Qwen3, and auto load is true, so that's all you have to set. It will automatically load everything. Don't worry. The model path can be changed if you want to load a different model in the future. For now, it's just a simple auto load is true and hook it up. Nice and easy. The next thing you need is the query. This is the user's query. This is what are you trying to have it inference? So what are you asking it to do, or what question are you asking it? For this, you need a text node. You get double click, select the text node, and you can add the query like this, connect the text to the query. Okay. And the final thing you need is an output here. For the output, again, the query is going to be connected to, this is going to be your original query. So you actually want to take the response. So again, double click, create a text node. Response goes into the text connection. So now you have the response that will show up here. So at this point, this is enough to have a very basic agent, and it doesn't have a system prompt and it doesn't have any memory, but that's okay. So you can ask it something like hello, and now it might fail because of these text nodes that are not connected, but it should still execute this. So let's see. When you have this basic 1, 2, 3, 4, when you have this basic 4 node agent, it might work, but we might need a system prompt. Let's see. So cue the prompt. It says system prompt is required, right? So if you need a system prompt, again, let's go ahead and double click and select the text node, and we can hook it up like this as a system prompt. But as you can see, we already have this system prompt node here. So all we're going to do is actually delete this by double clicking, hitting delete. And this is our system prompt here. And we're going to connect it nice and easy. So we can just rearrange it like this, maybe because these two parts are above and something like this, for example. All right. And yep. So at this point, we can try to run this again and see if it passes. Yep. As you can see here, with the query of hello, it said, hello, how can I assist you? So it is working and it does one run. This issue was because of the error that we got with the system prompt. So as you can see, the basic agent is 1, 2, 3, 4, 5 nodes. That's the most basic agent that you can build. And technically, you could deploy this, but again, it's not autonomous. If you wanted it to be autonomous, we'll talk about it in just a minute, but you would just hook in the scheduler node, and what you would do is you create a trigger and pass it to your input, to your query. Right. And so this is session what we would do is the trigger node is going to trigger this query every between 5 to 10 seconds. So if you wanted to run this, you would just now, instead of qprompt, which would execute this once, you would hit run. And now you will see that it's going to execute it and keep outputting a slightly different response. It might output the same one as well, because you're just asking it something simple. But as you can see, it also changes here. So this is how you'd make it autonomous, and technically this would be enough to deploy and have it run. But as you can see, all it would do is just do this over and over and over. So not very useful, but technically speaking, this is an autonomous agent. So for now, let's take this autonomy out of the way, and let me show you guys the memory aspect, which is not as hard as you think. So now we have this basic 5-node agent. Let's go ahead and add memory. Double click, and you need a couple of different nodes for this. The first thing we would add is the memory storage. So for memory, you would need to store this memory somewhere in some path or some sort of object or some instance. So the memory storage node creates this instance with a storage path of default and a storage type of local. So you can just leave everything as default. And the other thing you need is the memory selector, which is a node that's going to select the memories from available memories and pass it to the model. So the first thing you do is you connect the memory storage instance to the memory selector instance, because it needs to know where to get the memories from. And the next thing you have to do is, well, the memory selector also needs the user's query to figure out, based on this query, which memory is relevant. Okay, and then after it selects the relevant memory, it outputs it as context, which you feed back into the inference. So let's move it out here a little bit. So it moves it back into the inference node as the context. Now, we could also, as you can see here, has a query output. This is essentially passing through the first query, the original query, to as the output from the memory selector, but it's going to happen after it's done its logic. So you can technically also wire this up this way, where you can see the initial query goes to the memory selector, passes through, and then you pass it through to the inference node. So this would work perfectly fine, and actually it looks a little bit better. And this is why we implemented this pass-through of the original query, so that you can have a little bit of a better connections. So it looks a little bit better. It's quite the noodle soup already. So now at this point you have a memory selection process that takes your query, figures out a proper context, and adds it to the inference node. But now you also need a post-inference memory creation protocol, which you can implement through the memory creator node. And as let's think about this logically. The first thing, when you are going to create the memories, we need to store it somewhere. And yes, you want to store it into the same storage instance. So that is why we hook it up right into the storage instance input here for the memory creator. The next thing is, well, to create the memory, you're going to need the query that the user inserted. You can again hook it up through this point, which makes the most sense, logically speaking. But technically, you could also hook it up the query through here because it's the same query, and you could even hook it up like this, right? But in our case, we're just going to hook it up through the final inference because it just makes more sense this way. So after it gets the query, it also needs the response. So this is going to hook up right here as the response. Now the user ID, I haven't mentioned it, but we do need a proper user ID, and that's why we have this extra node here for the user ID and its default user. The reason we need this node is the default user specifies which user are we searching the memories for and creating the memories for. So it is important, and we're going to hook it up to the memory selector and the memory creator as the user ID. In the future, the reason why we abstracted this into a node is that this user ID can be coming from Telegram, and it can be a certain user ID, or it can be coming from your web API, where it defines a specific user ID that's talking to it. And it is important to specify specifically for the memory. But it's very easy to pass it along if you decide to implement this. But for now, if you don't want to implement this, you can just include a default user, and nice and simple, it will work out of the box. Another thing we forgot is for the model. As you can see here, we have a model and LLM inputs. We're going to collapse them into a single model input, but it looks like this. You hook it up to the model. And so this is, again, using the same Qwen3B model to select the memories, because the memory selector also includes a sub-agent. So you can think of the memory selector as having its own inference node, its own system prompt node, and its own, I believe that's it. So its own inference and a system prompt. In a way, that's what the memory selector does with some extra features, including the recent conversations buffer. So we do need to hook up the model to both the memory selector, the inference, and the memory creators. All right, and for now it has the model LLM, but we'll remove this option. Right, so at this point, we have the memory creator that creates the memories into the storage, the selector selects them, and everything should work good. At this point, you should be able to have an agent that has basic memory. And here's how to test this. First thing you want to do is just do a basic sanity test to make sure that this agent is able to output hello, make sure we wired everything correctly. All right, here we go. Everything is good. And now you say, my favorite color is green. Please remember that. I'm going to tell it to remember a certain fact about us and see. And then in the follow-up prompt, we're going to ask it if it remembers our fact. So here it is. It said, okay, green has always been my favorite color. Great. So now what we're going to do is ask it, what is my favorite color? And now, before we even run this, we want to figure out, okay, well, how is it going to remember it? From the memory selector, no, their logic is the memory creator runs only once every 3 interactions. So if this is our second interaction, it's not going to run the memory creation, but the memory selector always includes a recent conversations buffer of 10. So it includes 10 recent conversations, which means that it should include the previous message that I sent it, where I told it my favorite color is green. And so this is the hypothesis, and if the memory works, then it should correctly output this. So let's check. Yep, it says your favorite color is green. So as you can see, the memory now does work, and that is exactly how we can tell. So there it is. You guys hooked up a basic memory agent. Now at this point, if you want to hook up the autonomy to this, you would simply bring in the scheduler node. We're going to add it in the menu. I think it's not in the menu yet. Yeah, but we will add it to the menu shortly. So the scheduler node outputs a trigger in which you hook it up to the, not the system prompt, but to the input prompt. But technically, you could hook it up to any of these nodes. Why? Because the way this autonomous layer works, the way this trigger works, it will check this node and it will find the subgraph for this node, which is all of these nodes. They're all interconnected. And then it will execute this subgraph through the engine. So technically, this trigger can be connected to any of these nodes. Doesn't really matter because it will just execute this full subgraph. If that makes sense. And at this point, if you want to test this out, again, you should give it maybe a nice prompt where it can generate a little bit more of different responses. So something like, "Hello, please describe yourself in one sentence." Unique. I don't know. Make it unique so that it is going to output something a little bit different so we can see. So then once you're ready, just hit the run button and you should be able to, as you can see, when it does the flashing, it means that it got the response from the back end, that the workflow was executed and in which order. And then it does a little animation to show you. As you can see here, it constantly changes the response, which means that it's working. And here we go. This is the basic autonomous agent. At this point, you would be able to simply hit the deploy button to deploy this agent to our servers, and it comes with a post API endpoint. So in the future, you could also hook up an API endpoint node so that if somebody sends a message to it, it'll essentially cause a trigger. This is a great way for you guys to build agents and abstract it in a way and also deploy them and have all the code available, fully open source, and you fully own 100% of everything. The best part is this is a locally hosted model, super loaded in quantized mode, so it's very optimized to run on your own local devices or if you want to run it in the VPS. So this is most everything I wanted to mention so far about the visual editor that we are building. And I'll just talk a little bit briefly about the NFTs because those are going to be even more powerful when we launch the token and start doing more beta testing on the platform. So for the NFTs, you guys can go to the obelisk.ai. These are reflection NFTs. When the energy token launches, which is going to be the official agent token for the obelisk, 2% of the LP fee is going to be distributed among 100 NFTs. Now, the reason why I have this calculation here is because if we are doing a 2% LP fee and then we have 100 NFTs and we distribute the LP fees around on average between the 100 NFTs, that means that each NFT gets around 0.02% worth of LP fees. So you can think of each NFT being worth 0.2% of LP fees. Now, this is assuming we get 500K in volume. If things go well, if we do enough, then that means that each NFT's value should be around $100. So at this price, as if you think about this, these NFTs right here that are on sale for 0.01 ETH, 0.02 ETH, even 0.03 ETH, they're actually, we're giving it to you guys for a really low and cheap price. These are a little bit more expensive, but you were assuming 500K in volume, which is relatively low. You know, if a lot of these projects they can get 2 million in volume in 24 hours. So don't underestimate. You do your own calculations, and the code is public as well. The NFTs are all open source or verified contracts. And so another cool thing is we have the Quantum Observatory. I wanted to mention the Quantum Observatory here for the NFTs. So we're going to be adding a link to this page, but for any of you guys that did manage to grab an NFT, for example, here's one. When we minted the NFTs for you guys, we generated a quantum number for this, right? And so when we minted this, if you look here, we showed you guys it was used IBM Torino, the qubits used, the execution time, and here's the job ID. Now this job ID will be available. We're gonna make it more open in the front end so you can find it. But you can take this job ID, put it into the Quantum Observatory. This is for your NFTs. And you click Observing. Now this is gonna grab the job ID from IBM Quantum directly. You can technically do this on your own. If you grab your own IBM Quantum API key, you should be able to query the same job ID to get the official results. So here's the results. We kind of made a little bit of an illustration for you guys. The back end that was used to generate your NFT was, let's say that this is a specific NFT that was used. So for NFT number, I believe this was for number 6. For NFT number 6, it was this job ID. It was created on January 24th. It used a physical qubit processor Heron V1, which had 133 qubits. It used qubits number 39 and qubits number 110. Exactly, see? And this is kind of what happened. The official circuit diagram, this is the hammered gate, and this we took the two qubits, decided to take qubit number 39 and qubit number 110, put it in superposition, collapsed. And then when it collapsed it, this one got a 0 and this one got a 1. Or sorry, no, I'm not reading this right, but because we did a bunch of results here, as you can see. We did 128 shots, and each shot used 2 bits because we used 2 qubits. And what we did was repeated it 128 times, and then those are the results we got. Those are the distributions. Based on distributions, we concatenated everything. We got a 256-bit quantum seed, which we converted to a decimal number, and that is how your beautiful seed was generated for your NFT. And yeah, we're just hope you guys. Some people I think ask who cares, and it's a very valid question. But this is just again like a research from a research point of view, and also from a novelty point of view. NFTs have always been about novelty and some having something unique. And I think grabbing an official NFT that was generated and the seed was generated with a quantum number, you can officially say you own a quantum NFT. I think it's really cool, and especially the utility for this that we are building. I'm really, really excited to see where it goes. So I think that's all about it. The last thing I just wanted to mention is, yeah, if you want to grab the NFT, you can grab it on our marketplace. We have our own custom marketplace that has 0 fees and only allows listings of our own NFTs. You can list, you can unlist at any point, as many times as you like. It's for 0 fees. So we recommend grabbing one of these 0.01 ETH NFTs. And a lot of you guys buying meme coins and losing way more than this for nothing. And I think here, just a small amount can go a long way. Not only because the reflections will be earned, but let's say if you try to even sell it for 0.003 or something like this, or 0.004, I believe someone will try to buy it quickly. So yeah, we start giving us plenty of opportunity before the token launch, because once the token launch happens, these guys will start earning reflections, and they wouldn't really, you could still technically sell them for less than the amount of reflections they earn, but the owner will directly earn reflections. The owner of the NFT, when for every swap, it will directly get the reflections. No claiming needed, no contract interaction needed. So we're super excited to share this with you guys, and I hope you guys can follow us on X and make sure to check out the Cabal's YouTube channel. Have a good rest of your week. See you in the next one. Peace.